In this video, we're going to focus on adding and subtracting our rational expressions. So just as a little review, do you remember how to add or subtract fractions together? What do you need? You need the same denominator before you can actually do the addition or subtraction. So if we're looking at our first question, we got 1 over 2 plus 3 over 4. We need the same denominator. So we're looking for the lowest common multiple between 2 and 4, and that happens to be 4. So we're going to take our first fraction and multiply both the numerator and denominator by 2. Because when we multiply both numerator and denominator by 2, our denominator is going to be 4. So our new fraction is 2 over 4, and that means we can add 3 over 4. So this then just becomes 5 over 4. And in our second question, from our denominators we have 3 and 4. So we're looking for the lowest common multiple between 3 and 4. And sometimes we'll need to multiply both numbers together to get that lowest common multiple. So our lowest common multiple here is going to be 12. So if we take our first fraction, we can multiply both numerator and denominator by 4. So we're going to get 4 over 12. And then our second fraction, we're going to multiply the entire fraction, both numerator and denominator, by 3. So that's going to become 9 over 12. Now we can actually subtract. So 4 minus 9 is negative 5, and we're going to keep that denominator the same. So when we're adding and subtracting rational expressions, we can follow the same process. And we want to add 4 over x plus 2 with 2 over x minus 3. So this time, our denominators are polynomials. We have x plus 2 in one rational expression and x minus 3 in the other rational expression. And we still need to look for the lowest common multiple between those denominators. And that actually occurs when we just multiply our denominators together. So our lowest common multiple in our denominators is actually just x plus 2 multiplied with x minus 3. So we're going to have to multiply by something to ensure that each of our rational expressions has this lowest common multiple in their denominator. So if we take our first rational expression here, 4 over x plus 2, we're just missing this x minus 3, so we can multiply by x minus 3. And remember, when we're multiplying rational expressions, we need to multiply both the top and the bottom. So we're going to multiply the denominator and the numerator by x minus 3. And then if we're looking at our second rational expression, we have 2 over x minus 3. We're just missing that x plus 2, so we want to multiply both the numerator and denominator by x plus 2. So when we actually do that multiplication, we're going to get 4 times x minus 3 over x plus 2 times x minus 3. And then we're going to add 2 times x plus 2 over x minus 3 x plus 2. And now that we have the same denominator, we can rewrite this as one rational expression over the same denominator. So let's do our addition, but we actually can't add anything in the numerator yet. We need to get rid of these brackets and distribute. So we want to distribute this 4 into those brackets and then distribute our 2 into the brackets. So it becomes 4x minus 12 plus 2x plus 4. And that's all over x plus 2 times x minus 3. And now we can start adding and collecting our like terms. So our numerator becomes 6x minus 8, and that's all over x plus 2 times x minus 3. So remember, just like rational numbers, our denominator stays the same. So this might be able to be simplified even further. Remember back to our last lesson when we needed to factor and cancel out any of our common factors within the numerator and denominator. So let's actually factor our numerator and see if there is a common factor. So if we factor out 2, that's our greatest common factor between 6x and negative 8, we would get 2 times 3x minus 4, and that's over x plus 2 times x minus 3. So as you can see, it doesn't look like there is a common factor between the numerator and our denominator. So this is our fully simplified expression, but we need to state our restrictions. So we need to find out what x cannot be. That'll make this denominator equal to 0. So starting at the beginning, we have x plus 2 in one denominator and x minus 3 in the other denominator. So we know that x cannot be equal to negative 2 and x cannot be equal to positive 3. Now looking through each line, did we have to do anything to the denominators to add another factor? And no, we didn't. So these are our only two restrictions. So in this next example, we have 4x minus 3 over 4, and we're going to subtract x plus 2 over 3. So we still have two rational expressions, and we need the same denominator in order to do this subtraction. So we're looking for that lowest common multiple between our denominators, between 4 and 3, and that's going to be 12. So that means we need to multiply our first rational expression all by 3, both numerator and denominator, and then we're going to multiply our second rational expression by 4. So I'm just going to rewrite this all over our same denominator. So this is all over 12. And now we can distribute and get rid of these brackets in our numerator. So this is going to be 12x minus 9, and then we're distributing this negative 4 into the brackets, so it's going to become negative 4x minus 8, and that's all over 12. So now we can do our subtraction and collect our like terms. So 12x minus 4x is 8x, and negative 9 minus 8 is negative 17. So it is 8x minus 17 over 12. So now we want to see if we can factor anything in the numerator or denominator even more so that we can potentially cross out any of our common factors from the numerator and denominator. And our numerator is actually fully factored. We don't have a common factor between 8x and 17. So that is fully factored, and we can't cross anything out between our numerator and our denominator. So this is our fully simplified expression, and we need to state our restrictions. But if you look at this example, starting from the beginning, we don't even have a variable in the denominator, and all the way through, we never put a variable in the denominator. So our denominator stays as a number. It can never equal 0, so we don't have any restrictions on our variable. So that is our final answer. So in this next question, we want to add 4 over x minus 2 with 3 over x minus 2. So looking at the denominator, we do have the same denominator, so we don't need to multiply by anything to get the same denominator. We can just do the addition right away. So we're doing 4 plus 3, and that's 7 over x minus 2. But we got to state our restriction because in this question we do have a variable in the denominator, and our restriction is just that x cannot be equal to positive 2. So looking at this next question, we have 1 over x minus 1 minus 1 over 1 minus x. And looking at these denominators, they look very similar, but they're not exactly the same, so we can't do our subtraction yet. So I actually want to look at our second denominator, 1 minus x. And I'm going to rearrange this so that we have x in the front. We're going to put x first. So this is the same thing as negative x plus 1. So that is a little more similar to this x minus 1 because they're in the same order. But what happens if we factor out a negative 1? We factor out a negative 1, it becomes negative 1 times x minus 1 in brackets. So we do have this x minus 1 that's common here. So this could be our lowest common denominator. So that means our first rational expression, we could actually multiply this by -1. So that's just going to become -1 over -1 times x minus 1, and I'm just going to rewrite that second rational expression just like we have it over here, -1 times x minus 1. So now we have the exact same denominator, and we can rewrite this over our denominator. So it's -1 minus 1 over -1 times x minus 1. So when we do that subtraction, that's really just -2 over -1 times x minus 1, and we can simplify this, -2 over -1. So our rational expression is just going to be 2 over x minus 1. And don't forget to state the restriction on our variable, so x cannot be equal to +1. So here's our next question. We have 3 over 2x plus 4 over 5x, and we need the lowest common multiple in our denominators. So there is an x in both denominators, but with a different coefficient. We have a 2 and a 5. So between 2 and 5, our lowest common multiple is 10. So actually in this question, our lowest common multiple is going to be 10x. Don't forget about the x. So that means we can multiply our first rational expression all by 5. And we're going to multiply our second rational expression by 2. So that's just going to become 15 over 10x plus 8 over 10x. And then we can just add that. So 15 plus 8 is 23 over 10x. Now always check after you've done the addition or subtraction if you can simplify this any further. And in this case, we cannot simplify this any further, but we do need to state our restrictions. So we have an x in our denominator. In this case, x is just being multiplied, so it cannot be equal to 0. So looking at this next question, we're adding these two rational expressions, and in the first we have 3 in the denominator, and in the second we just have x minus 2 in the denominator. So our lowest common multiple between the two is just 3 times x minus 2. So that means we're going to take our first rational expression and then multiply both the numerator and denominator by x minus 2. And then we're going to take our second rational expression and multiply the numerator and denominator by 3. So this then just becomes 2 times x minus 2 over 3 times x minus 2 plus 15 over 3 times x minus 2. And we can rewrite this all over the same denominator. And now I know you see that there is something common in the numerator and denominator, that's the x minus 2, but we can't cross that out yet. Our numerator is not in factored form yet because we have this 15 at the end, so we definitely cannot cross out this x minus 2. So what we really need to do here is distribute this 2 into the brackets. So that's just going to become 2x minus 4 plus 15, and this will just allow us to collect any like terms that we have. And now when we do collect our like terms in the numerator, this will become 2x plus 11, and that's all over 3 times x minus 2 in brackets. Now it doesn't look like we can factor this any further, so we won't be crossing anything out within the numerator and denominator, but we can always state our restrictions on that variable. And x cannot be equal to positive 2. In this next question, let's look at our denominators. So our first rational expression has a y in the denominator, and our second rational expression has an x in the denominator. So our lowest common multiple is just going to be when we multiply those together. So it's just going to be x times y. So that means our first rational expression, since we have a y in the denominator, we're going to multiply everything by x. And in our second rational expression, we're going to multiply everything by y. So I am just going to rewrite this all over the same denominator. So it's x times x plus 2. And because we're subtracting, we're going to put minus y times y minus 2. And that is all over our denominator, x times y. And let's get rid of the brackets in the numerator. So we're going to distribute. So it's going to be x squared plus 2x minus y squared plus 2y. And that is all over x, y. Now, can we simplify this? Are there any like terms in the numerator that we can combine together, or can we even factor anything out? It doesn't look like there are. So since we can't do anything else with this expression, we're just going to state our restrictions. So we have an x and y in the denominator throughout the question, and they're just being multiplied together, so x cannot be equal to 0, but also y cannot be equal to 0. So here's our next question. We have 4a over a plus b plus 2 over b. So looking at this here, our denominators, we have a plus b and b. So our lowest common multiple between the denominators is going to be when we multiply those together. So it's b times a plus b. And that means we're going to multiply our first rational expression all by b. And we're going to multiply our second rational expression all by 1 plus b, both numerator and denominator. So if we rewrite this expression all over the same denominator, it's just going to be b times 4a plus 2 times a plus b, and that is going to be all over b times a plus b. So let's get rid of those brackets in the numerator. I actually want to keep the denominator as is in factored form, but the numerator, when we distribute, it's going to be 4ab plus 2a plus 2b. And that is all over b times a plus b. And looks like in the numerator we cannot combine any like terms, we cannot simplify this any further, we cannot cross anything out. So all that's left to do is state our restrictions. So we know that b cannot be equal to 0, but we also have a plus b in the denominator. So what would make a plus b equal to 0? So we need to figure that out. When is a plus b equal to 0? If we rearrange this and isolate it for b, b cannot be equal to negative a or vice versa, so that is in fact one of our restrictions.